algebra, we are moving on to CO35, graphing a linear inequality on the coordinate plane. So we've graphed equations before, and to graph an equation, we used slope-intercept form. We're actually going to kind of do the same thing. Paul, warning for you, we're recording. We're actually going to use the same method here. Ryan, Briggs, warnings for each of you as well. We are recording. We're going to use the same thing here, but again, we need to remember that we are dealing with inequalities, so we have these symbols of less than, greater than, less or equal to, or greater than or equal to. Okay? And we're going to start by using 3x minus 4 as an example. Y is less than 3x minus 4. Now, using slope-intercept form, what would we do first here? What would we do first? Y equals mx plus b. Did we all forget how to graph in slope-intercept form?
Yes.
Think about it. Y equals mx plus b. The m and the b, the slope, the y-intercept. Katie, stop. Paisley.
You start with the y-intercept, and if the number is negative, it's below the middle of the.
No.
It's below the middle of the graph, and if it's above, and if it's positive, it's above.
Right. We start that y-intercept point first. Okay. And we've got this -4 as our b value. So on the coordinate plane, we're going to go down to -4, and we're going to plot a point. Okay. How do we get our second point? Slope, which is what? 3/1, right? So from this y-intercept, we're using our slope up 3/1. And I don't want you to connect these points yet. Because after you plot the points, here's where the inequality kicks into play. Okay? Because dealing with less than or equal to symbols, you know how we have that open circle, closed circle?
Yeah.
What did an open circle mean with an inequality when we graphed it on the number line? Colin? Right, it wasn't an actual solution to it. What did the closed circle mean? I mean, it could have been a solution to, right? The open circle was for greater than or less than symbols, and the closed circle was for that or equal to piece. Okay? We have a less than symbol here. And so this question that I ask you, will the line in the graph be dotted or solid? A dotted line you use in place of an open circle. Okay? We don't want to put a bunch of open circles on our line going up, connecting the points. We put a dotted line instead. That represents that open circle that we would have had with just one variable on the number line. A solid line represents the closed circle. Okay? So in this case, because that less than symbol, when we connect these points, do so with a dotted line, which makes it even harder to draw it straight, but do your best. Right? And then you already answered this question. What did that open circle mean? The open circle meant, like if we had n is less than 4, it meant that n couldn't actually be 4. What do you think the dotted line represents on this linear inequality? Nick?
It could be that way.
What do you mean it could be?
Like it isn't like 100% sure, but it's like possible that it could be.
Okay. That y can never be equal to 3x minus 4, meaning that these ordered pairs on the line that in an equation would work in the equation. Pick an ordered pair that's on the line here. Let's go up 3/1 a second time to get a third point, and let's use 2, 2. Excellent. Plug in 2, 2 into our inequality. This is why we did this in CO34, right? Kind of practicing this here. Plug in 2, 2 into our inequality, and we get 2 is less than 6 minus 4, which is 2. Is 2 less than 2? No. 2 is not less than 2. So this dotted line means that none of the ordered pairs that are actually on the line make the inequality true. Just like when we had n is less than 4, that 4 didn't actually make the inequality true. So if our solutions aren't on the line itself, where are they? Elsewhere, right? Remember the other piece with solving inequalities before was when you had something like this, n is less than 4, we had to plot that 4 on a number line, put our open circle on, and then all of our solutions were elsewhere, anything less than 4. Okay? In this case, we get to shade one entire side of this linear inequality to show where the ordered pairs are going to work. So, Caitlin, pick an ordered pair that is elsewhere, not on the line. Negative 1, 1. Okay? We're going to plug that ordered pair into our inequality and test it. Y is less than 3x minus 4. We're plugging in negative 1, 1. So in goes 1 for y. In goes negative 1 for x. Minus 4. 1 is less than negative 3 minus 4, which is negative 7. Is 1 less than negative 7? This is not true. That means that negative 1, 1 is not a solution. Do we need to continue to test ordered pairs until we find one that is a solution? Thankfully not. Okay. There are two sides to this inequality, right? All the ordered pairs on one side will not work. All the ordered pairs on the other side will work. So if the ordered pair that you test doesn't work, you know that none of the ordered pairs on that side of the inequality are going to make it true, which means that all of our solutions are over here. So instead of shading in or pointing to one side of a number, like we did, like n is less than 4, we just pointed to one side of the number, we now get to point to an entire side of a line, because all of those solutions are going to work. If Caitlin had chosen something over here, like 5, 0, okay, which is on the other side of the inequality. Let's test the ordered pair 5, 0. Y is less than 3x minus 4. 0 is less than 3 times 5 minus 4. 0 is less than 11. Yes, that one works. As does every single other ordered pair on that side of the line. Okay? So with linear inequalities, the graphing part of them, how you get the ordered pairs, exactly the same as an equation. Y-intercept, slope. But then, is it a dotted line or a solid line? That's, you look at the symbol for that. Which side you shade. Okay? That's where you can plug in ordered pairs to test. Cool.
Did you go to St. John's because you're wearing a hat?
Yes, I did. Questions so far? Okay, we're going to skip this table for just a minute here, and we're going to go down to this bottom section. Graph each linear inequality. Y is greater than 2/3 x plus 1. Start with slope-intercept form. Where's our y-intercept here? Positive 1. Plot that point. There it is. What's our slope? 2/3, meaning from this point, we're going up 2 and over 3. Okay? Just like slope-intercept form. But now that we got the points plotted, here's where the inequality kicks in. Is this going to be a dotted line or a solid line? And how do you know it's dotted? What tells you that? The inequality symbol, right? Since it's just greater than, this is what tells you it's going to be dotted. Meaning that all of these ordered pairs on the line itself are not going to work. Okay? And make your dotted line very obvious, on the test. I'm going to have to be able to tell whether it's a dotted or a solid line. Okay, now which side do we shade? Where are our solutions? Give me an ordered pair that is not on the line itself. Finn, what do you want to test?
How about -4, 3.
-4, 3. Okay? So into our inequality, we're putting -4, 3. So 3 is greater than 2/3 times -4. That's kind of nasty. Plus 1. Luckily, that negative x is going to bring us negative. And so we have 3 is greater than -8/3 plus 1. Adding 1 whole to -8/3 is not going to bring me positive. It's definitely not going to bring me to positive 3. So even though we kind of have that nasty fraction there, we can look at this and say, oh yeah, 3 is going to be greater than whatever -8/3 plus 1 is. So because that ordered pair works, what does that mean we do with the side containing that ordered pair? We shade it, because that's where our solutions are. Okay? In order to avoid those nasty fractions there, what's a smart ordered pair to pick and test? That you can usually pick every single time unless the line passes through this point. Well, what's a smart point to pick? 0, 0. Okay, 0, 0, 0 is an easy number to work with. We can see that this 0, 0 is on the bottom side of this line here. And if we were to plug in 0, 0, is 0 greater than 2/3 times 0 plus 1? Well, the brilliance of using 0 is what happens with that nasty fraction. It goes away. Because anything times 0 is going to be 0. You're really just left with comparing your y-intercept. Is 0 greater than 1? No, it's not, which we already knew because we don't shade that side. Okay? Colin, question or observation? I think I know where you're headed. Can you save it for just a minute here?
Yeah.
Okay. Cole.
Do we have one more?
You will. The next one. Y is less than or equal to -3x plus 2. Where's our first point getting plotted? Positive 2. Our y-intercept. Okay? Where are we going from here? What's our slope? -3 over 1. Right? Remember, it is over 1. Down 3. Right 1. Wasn't very accurate. Okay? Is this going to be dotted or solid? Solid. How do you know? Yes, it's got that less than or equal to piece, which means that every ordered pair on this line is going to work, just like an equation would. But because it's an inequality, so will a whole bunch of other ordered pairs work. And that's where the fun part of the shading comes into play. Let's test 0, 0, because now we're smart. We're cooking. Yeah, very good. So 0, 0. Is 0 less than or equal to -3 times 0 plus 2? Again, the magic of that 0 takes that slope away completely, and we're left with, is 0 less than or equal to 2? Yes, it is. So does that ordered pair work? Does every other ordered pair on that side also work? Yes. This is the side that we are shading. Okay. Yeah, every year I say I should change that 7 to something that's actually on the corner plane, and I always forget.
And there's 2 more joke running at the back page.
That what?
There's a 9 and a 12. Oh, yeah, there's a 9 and a 12.
There's a 12?
Yeah.
Oh, those are in standard form though. So you have to convert them to subvariance form first. See how my eagle laugh button would fit perfectly here right now. Gosh. So, even though it's off the coordinate plane, we're still going to plot it. We can be smarter than the coordinate plane. The coordinate plane goes up to 5, 6, 7 would be right about there. Okay? Just a little bit higher. Our slope, -5/2, means we do what? Down 5 over 2. So 7 minus 5 is positive 2 over 2 brings us here. Is this going to be dotted or solid? Solid. And we know that because it has that or equal to piece. On a number line, it would be a closed circle. But on the coordinate plane, it's a solid line. which means that every ordered pair on the line does work, along with an infinite number of others. And we're going to decide which side those are on now. Plug in 0, 0, because that's the smart way to do it, especially with that fraction there. Is 0 greater than or equal to negative 5 halves times 0 plus 7? Is 0 greater than or equal to 7? It is not. So do we shade that side? No. We shade the other side. Okay. All right. 3, 2, 1. You are quiet.
You're done.
Colin, I will now let you speak.
I have made an observation.
Share your observation. And just so you know, I have a button that whenever a student makes a great observation, it plays like the MCU Avengers music, but I don't have my buttons loaded, so I can't play it. But just imagine. Go ahead.
So, if it's a dotted line, if it's less than, the shaded side is the right side. If it's greater than, the shaded side is the left side. If it's a solid line, it's the other way around.
Interesting. What?
I'll tell you that you are close. Instead of left and right, we're going to use the words above and below. Okay? Let's go back to this table here. And this table can be viewed. It's a key point. Palter around. So can be put on a help sheet. Okay? If your inequality is a less than symbol, the boundary line, which is the line that the ordered pairs make, is going to be dotted. If it's a greater than symbol, the boundary line will once again be dotted. We already talked about why. The solutions aren't actually on the line itself. If you have a less than or equal to symbol, your boundary line is going to be solid, because it's like that closed circle. The solutions are on the line. It includes those ordered pairs. If it's greater than or equal to, it is going to be solid as well. Okay? Where Colin was going here is that, we spend our time testing ordered pairs to see which sides of the line works. You can use the inequality symbol to tell you as well. If your symbol is the less than or the less than or equal to symbol, you will always be shading below your y-intercept. Okay? If you've got the less than family symbol, it doesn't matter if it's or equal to or not, you are always shading below the y-intercept. Let's just take a look here. Okay? In our second example, we had the less than or equal to symbol. Our y-intercept was positive 2. We shaded everything below that. Right? All the y values below positive 2, that's the side of the graph that we shaded. In our first example, the one that we don't have the ink for anymore, that y is less than 3x minus 4, whatever it was, we shaded everything below our y-intercept. If it's the greater than or the greater than or equal to symbol, that family, you are going to be shading above the y-intercept. Whoops, above y-intercept. Okay, and the two examples that we have, our first and our third one here, y is greater than 2x plus 1, we shaded above that y-intercept of positive 1. Right? Every y value above that was part of our solution side. On our last one here, even though our y-intercept is way off the graph, okay, the side that we shaded includes, if we went up higher here, all the y values above that positive 7. So really, and Sam, Nathan, I'll give you just a second here, really your inequality symbol tells you everything you need to know about graphing this linear inequality. It tells you whether it's dotted or solid, and it tells you which side to shade. Right? Now the backup is testing an ordered pair, and 0, 0 is really easy to test, but your inequality symbol tells you everything you need to know about whether it's dotted or solid and which side is shaded. Sam, go ahead.
I have an observation.
Go ahead.
2 plus 2 equals 17.
Nathan,
What if it's a straight line though?
all lines are straight.
Well, I'm sorry.
Well,
I mean,
like,
like,
up and down.
Vertical line?
Yeah.
Well, vertical line doesn't have any slope. It's undefined, right? So that would not be applicable. Wait, so a vertical line, just to answer your question, if we had a vertical line going like that, okay, what would the equation of the vertical line be?
0.
Y equals 0.
The equation of that vertical line there is x equals 4, right? X equals 4. And if we're shading one side of that line, say this side, we shaded the values that are greater than 4. We only need a number line for that. Right? So really, in a sense, you've been graphing these vertical lines all along because all you need to graph them is a number line because they're vertical lines. Their slope is undefined. Therefore, you cannot graph this using slope intercept. Okay? Valid question. But there you go. All right, your homework. The second. Hey, first of all, any questions on this table? Because this is literally the key point to let this everything. Nick,
you made this, were you mad at your kids?
what's that?
When you made this, were you mad at your class?
No, why? No, because we've done that before.
Because you
Okay. PO22. Some of you still have not passed PO22, which is converting from slope intercept. This is good practice for that, right? This is good practice for that. If you never practice the things you struggle with, you'll never get any better. Okay? If you only do what's easiest, you're never going to improve. Okay? So, your homework is the second page of this. You'll notice that the bottom 3 are in standard form, which means you need to put them in a slope intercept form. Folks, hold up. Everyone look at me. I want the attention. Attention, diva. Look at me. This last one here, which is in standard form, like I said, you'll also notice you've got that -5 in front of the x. And so when you convert this into slope intercept form, be thinking, are you going to have to flip your inequality symbol here? That one before it, you've got that -4y. So just be thinking, when you convert into slope intercept form, are you going to have to flip the inequality symbol? That rule still applies because you are dealing with an inequality. Okay, Sam? I did not. Cool.
I have an observation.
I'm being honest.
I have an observation that you'd be a Viking fan, would you?
The what?
A Viking
That's not an observation. That's a dream that will not come true. Nick?
How do you? Can you just like refresh my memory? How do you convert to standard form?
How you convert from standard form to slope intercept form? So you want to move your x term over using opposite operations. So in this first one here, we'd start by subtracting 2x from both sides, right? That will give you 3y is greater than -2x plus 9, because you can't combine those terms because one has an x, the other one doesn't. Okay, so you put the x term out in front like that. And then who remembers what we do here? Colin? Divide by the coefficient to y, and you end up with y is greater than -2/3 x plus 3, and now that is in slope intercept form. So first step, move your x term over using opposite operations. Second step, divide by the coefficient to y, and then you have your slope intercept form. Okay. We did not have to flip our inequality symbol here because what we divided by was positive. So. All right. Questions, comments, concerns, complaints? Collins, congratulations, criticisms. Cole. For 8th grade, yes. And after school, yes. Probably. Manny. You mean? Nick? Sorry, go ahead.
Congratulations on finding such a good math lesson.
Thank you. Thank you. It's one of the best laid out lessons in the entire book, I think. All right, homework due tomorrow. That's it, math.
Don't forget to like and subscribe.